Hello friends, chapter number 11, dual nature of radiation and matter. Now friends, today we discuss about some history. So friends, we already know that from the Maxwell's equation and Hertz experiment, we know that light possesses a wave nature, right? We can conclude that from Hertz experiment and Maxwell's equation, right? Now friends, in 1895, Röntgen invented the X-rays, right? You already know this, right? But once again we recall it. In 1895, Röntgen invented the X-rays. Then in 1897, J.J. Thomson invented electron. You already know this, right? That J.J. Thomson invented the electron. And in 1870, Crookes invented the cathode rays, right? Now friends, the scientist named Crookes done some experiment. So the experiment will be like this. He filled a gas in a discharge tube and he applied the field to the electrodes. So he concluded that a negative charge produced and it travels to the other end. Now when this charge is incident at the fluorescent surface, then a yellow light flicker, right? Some flicker is there and the color is yellowish color, right? So this flicker occurs, and from this he concludes that the stream of this negative charge is known as the cathode rays. Once again I repeat, he filled gas in the discharge tube and applied the field to it. Now he observed that a negative charge produced and it is incident at the other end at a fluorescent surface. So he observed the flickering of yellowish light and he named that this stream of the charge is known as the cathode rays, right? So this is about the Crookes observation, that the stream of the charge is known as the cathode ray, right? So this is experiment that we have to remember. I repeat once again. He filled a gas in the discharge tube and applied the electric field. Now he observed that a negative charge is produced which is traveled to the other end and incident on a fluorescent surface. Then the yellowish flicker produced, and this stream of the charge is known as the cathode ray, right? Now friends, J.J. Thomson measured the speed of the cathode ray. He said that the speed of the cathode ray is 1 by 20 to 1 by 30 times than the speed of light, that is 3 into 10 raised to 8 meter per second. So a scientist named J.J. Thomson measured a speed of the cathode rays that is equals to 1 by 20 to 1 by 30 times than the speed of light, that is 3 into 10 raised to 8 meter per second. Also friends, he found the ratio of charge of the electron to mass of electron. So Thomson find out the ratio of E by M, that is equals to 1 by 76 into 10 raised to 11 coulomb per kilogram. That you have to remember friend, that the speed of cathode ray is 1 by 20 to 1 by 30 times than the speed of light, that is 3 into 10 raised to 8 meter per second. And the ratio of E by M for electron, that is equals to 1.76 into 10 raised to 11 coulomb per kilogram. And you have to remember that this ratio E by M not depends on the type of gas filled in the cathode tube, or you can say the discharge tube, and does not depends on the metals used as electron. So friends, this ratio of E by M is not depend on the type of gas which is filled in the discharge tube, or you can say cathode tube, and does not depend on the material, or you can say metals used as the electron, right? So friends, you have to remember this. Now there is another experiment which is carried in 1887, that when the ultraviolet light incident on some metal, and if metal are heated, then the electron emits from the surface of metal. You already studied this concept in chemistry, right? That when UV light incident on the metal, or you can say some metals are heated, then the negative charge, that is also known as electron, because J.J. Thomson names this negative charge as electron. So when a UV light incident on the metal, or you can say if the metal is heated, then the negative charge, or you can say electron, emits from the surface, right? And this negative charge having a name electron, that is given by J.J. Thomson, right? Then friends, in 1913, American scientist named R.A. Millikan measured the charge of electron, and you already know the charge of electron, that is 1.6 into 10 raised to minus 19 coulomb, right? So this charge of electron is measured by Millikan, and by the experiment of oil drop experiment, right? So you have to remember friends, a charge of electron is measured by the oil drop experiment, and the value of charge of electron is 1.6 into 10 raised to minus 19 coulomb, right? Once again friends, you have to remember these things. Röntgen invented X-rays, J.J. Thomson invented electron, Crookes invented the cathode rays. The experiment will be like this, that a gas filled in a discharge tube, and he applied field to it. Now he observed that a negative charge produced, which is traveled to the other head, and it is incident on a fluorescent material, then the yellowish flicker occurs, and this stream of the charge is known as the cathode ray, right? Then the J.J. Thomson measured the speed of cathode ray, that is 1 by 20 to 1 by 30 times. Then the speed of light, that is 3 into 10 raised to 8 meter per second, right? Then J.J. Thomson gives the ratio of E by M for electron, that is equals to 1.76 into 10 raised to 11 coulomb per kilogram. And you have to remember that this ratio E by M for electron not depends on the type of gas filled in cathode tube and the metals used in the electron, right? Now friends, some other experiment is like this. When the UV light incident on the metal, or the metal is heated up, then negative charge emit from the surface, and this negative charge name is electron, that is given by J.J. Thomson. And American scientist named Millikan measured the charge of electron by oil drop experiment, and the charge of electron is 1.6 into 10 raised to minus 19 coulomb, right? Now friends, we start the chapter. Our first topic is electron emission, right? So friends, this is the history and some introduction. Now our first theory is electron emission. Now friends, you already studied this concept of emission of electron in standard 11 in subject chemistry, right? And you already know that when the temperature of metal is increased, then the kinetic energy increase due to oscillation. Now if this kinetic energy is greater than the binding energy, then the electron emit from the surface, right? So you already know the concept, right? So same, see, when the temperature increase, kinetic energy increase due to oscillation. Now when the kinetic energy is greater than the binding energy, then the electron emits from the surface. Now we know that there are two types of ions are there, positive and negative. And we know that there is a force of attraction between positive and negative ion, right? So here, if there are positive and negative ions, so there is a force of attraction between them. So due to this force of attraction, electron cannot be emitted. So if I say, if the energy of electron is greater than the energy of attraction, then we can say that electron emits from the surface, right? So once again, when the temperature increase, kinetic energy increase. But friends, if the kinetic energy greater than the binding energy, then electron emits from the surface of metal. But we know that friends, there are two types of ion, positive and negative, and there is a force of attraction between this positive and negative ions. So if the energy of electron is greater than, or we can say more than, the energy of attraction, then we can say that the electron emits from the surface, right? So here see that due to the attractive force between the positive and negative ion, electron attract to the surface. So when the energy of electron is more than the energy of attraction, then the electron emits from the surface, right? Now friends, to emit the electron from the surface, we have to apply some energy. So friends, the minimum energy required to make electron escape from the metal surface is known as the work function, right? So friends, what is work function? So the minimum energy required for electron to make the electron escape from the metal surface, that is known as work function. So what is work function? So you can say that work function is the minimum energy required for electron to escape from the surface. Now friends, the unit of work function is eV, that is electron volt, and the symbol of work function is phi, right? So we already know that what is work function. So it is the minimum energy. So we know that the unit of energy is joule, right? And work function is denoted by phi, and unit of work function is electron volt. So we already know the relation between joule and electron volt. We know that 1 eV, or you can say 1 electron volt, that is equals to 1.6 into 10 raised to minus 19 joule, right? So what is work function? So it is the minimum energy required for electron to escape from the metal surface. The unit of work function is electron volt, and it is denoted by phi. We already know the relation between electron volt and joule. 1 electron volt is equals to 1.6 into 10 raised to minus 19 joule, right? Now friends, there are three methods to obtain the emission of electron. First method is thermionic emission, second one that is field emission, and third one that is photoelectric emission. Now friends, first one, thermionic emission. So when the metal is heated up, then the electron escape from the surface, or you can say electron emits from the surface of the metal. So this emission is known as thermionic emission. Once again I repeat, when the metal is heated up, the electron emits from the surface of electron. This emission is known as thermionic emission, right? Second one, field emission. So when electric field of 10 raised to 8 volt per meter is applied at a metal, so when you apply electric field of 10 raised to 8 volt per meter to metal, then the electron emits from the surface, and this method of emission known as the field emission. So in field emission you have to apply the electric field of magnitude 10 raised to 8 volt per meter. So the electron emit from the surface, and this method is known as field emission. Last one, photoelectric emission. So in photoelectric emission, a radiation of specific frequency is applied to the metal, and due to this electron emits from the surface, and this type of emission is known as photoelectric emission. So friends, in photoelectric emission you have to apply the radiation of specific energy to the metal, and due to this electron emits from the surface, and this type of emission is known as photoelectric emission. So these are the three types of emission: thermionic, field emission and photoelectric emission. Now friends, this thermionic emission is used in diode and triode. We discuss about diode and triode in our chapter number 14, that is semiconductor. So you have to remember this type of emission, say thermionic emission, is used in diode and triode. We discussed about diode in our chapter number 14, semiconductor, right? So friends, there are three types of emission. In thermionic emission, metal is heated up, and due to this electron emits. In field emission, you have to apply the electric field having a magnitude 10 raised to 8 volt per meter. So due to this electron emits. And in photoelectric emission, you have to apply the radiation of specific frequency, and due to this electron emits from the surface. So this is about the different types, or you can say method, to obtain the emission of electron. Now friends, we discuss about photoelectric effect. Now what is photoelectric effect? So when the metal surface is irradiated with the radiation of sufficiently high frequency, electrons are emitted from the metal surface, and this phenomena is known as the photoelectric effect. So in this photoelectric effect, the metal surface is irradiated by the radiation of the sufficiently high frequency, and we know that if there is a high frequency, then due to this electrons emits from the surface, and this phenomena is known as photoelectric effect. Now friends, this photoelectric effect, you already studied this photoelectric effect in standard 11 in subject chemistry, right? Now we discuss about the Hertz observation. So we already know that Hertz produce the electromagnetic waves, right? Now what is Hertz observation? So Hertz observed that when the ultraviolet light incident on the metal surface, due to this the electrons which are near to this surface of metal gets the energy. So this energy is used to overcome the force of attraction, right? Because we know that there are two types of ion, positive and negative. So friends, when the ultraviolet light is applied to the metal surface, then the electrons which are near to this surface gets the energy. Why? Because these electrons absorb this energy, right? So due to this energy, electron are trying to overcome the force of attraction. So if there are sufficient energy, then we know that the electrons are emits from the surface. Once again I repeat, what is Hertz observation? So Hertz observed that when the ultraviolet light is incident on the metal surface, then the electrons which are near to the surface absorb this energy. This energy used to overcome the force of attraction, right? Now if the electron gets the sufficient energy, then these electrons are emits from the surface. So this is the Hertz observation, right? So friends, you have to remember this history, right, that we discussed. You have to remember these values. The speed of cathode ray, that is 1/20 to 1/30 times than the speed of light, that is 3 into 10 raised to 8 meter per second. You have to remember this ratio of E by M, that is 1.76 into 10 raised to 11 coulomb per kilogram, right? You have to remember this E by M ratio not depends on the type of gas and metals used as electrode. Now different questions will be asked from this. The question will be like this: what is work function? Give the unit of it, right? So we already discussed that. Second question is, give or explain the different methods to obtain the emission of electron. So we know that there are three methods: thermionic, field and photoelectric emission, right? And we already discussed about this emission, right? And last one, that is, what is photoelectric effect, and give the Hertz observation, right? So these are the questions which will be asked in your examination. Okay friends, thank you.